How's it going today? In this video, we're going to talk about the pH scale. Let's get started. We're going to start out today by looking at what the pH scale is and what it measures. Then we'll look at how to calculate pH based on the concentration of hydrogen ions. After that, we'll look at how to do the reverse and calculate the concentration of hydrogen ions based on the pH. Finally, we'll talk briefly about the pOH scale. You're probably familiar with the pH scale and know already that it measures the acidity of something. And you might remember that a pH below 7 indicates that something is acidic, while a pH above 7 indicates that a solution is alkaline or basic. A pH of 7 is considered neutral, and this is the pH of pure water, though most water is not actually exactly at a perfect 7. pH is calculated by taking the negative logarithm of the concentration of hydrogen ions. We'll look more at that formula in a bit, but first, this is a picture of the pH scale with everyday items placed at their approximate pHs. Obviously, there are a lot of other things that exist on this scale, but these can hopefully give you a decent reference point. As you can see, the stomach is very acidic. You might also notice that a lot of the food and drink on this list has an acidic pH, even dropping down as far as pH 2 for lemons. Sour foods tend to have some kind of acid in them. The stomach can handle very acidic contents, so generally consuming safe acids is not a big deal. Your mouth and esophagus, however, are not nearly as tolerant of acids, so you still can't go around drinking lab-grade acid. We can safely consume foods with pHs around 2 and 3, but bases are far worse for our stomach. That being said, antacids have a pH of about 10. So how does the pH scale actually work? Well, as we said earlier, pH measures the concentration of hydrogen ions in a solution. Since hydrogen ions are released by dissociated acids, the higher the concentration of hydrogen ions, the more acidic and thus lower the pH. The pH scale, however, is exponential in nature. A pH of 4 is 10 times more acidic, meaning it has 10 times the concentration of hydrogen ions, as a pH of 5. 4 is 100 times more acidic than 6, 1,000 times more acidic than 7, and so on. The formula for pH is pH equals the negative log of the concentration of hydrogen ions. The concentration of hydrogen ions in pure water is 1 times 10 to the negative 7th. Let's look at some examples of how to use this formula. So our first practice problem says that the concentration of hydrogen ions in a given solution is 3.16 times 10 to the negative 5th. What is the pH? So we know that pH equals the negative log of our concentration of hydrogen ions. So in this case, pH equals the negative log of 3.16 times 10 to the negative 5th. So all we got to do is plug that into a calculator, and what we will get is a pH of about 4.5. And pH doesn't have any units, so. The second question says the concentration of hydrogen ions in a solution is 1 times 10 to the negative 12. What is the pH? And so same thing, we'll just do pH equals the negative log of 1 times 10 to the negative 12. And in this case, that is going to give us a pH of 12. We can also reverse our calculation process to determine the concentration of hydrogen ions using the pH. To do this, we just need to solve our previous formula, pH equals negative log concentration of H, for the concentration of hydrogen ions. I won't go through that process here, since logarithms are a bit wonky, but the final formula is that the concentration of hydrogen ions equals 1 divided by 10 raised to the power of pH. Let's look at how this works. Alright, so our first question here says, what is the concentration of hydrogen ions in a solution with a pH of 2.2? So in order to find that, we're going to use our formula the concentration of hydrogen ions equals 1 over 10 to the pH. And in this case, our pH is 2.2, so we get H plus equals, that's concentration of H plus, sorry, 1 over 10 to the 2.2. And that, when we type it into our calculator, is going to give us about 6.3 times 10 to the negative third. And we won't go over units of concentration here. It's a little bit complicated, so we're just going to leave it as is. This one, what is the concentration of hydrogen ions in a solution with a pH of 12? Now, interestingly, I already actually asked you the reverse of this question on the earlier slide, but H plus equals 1 over 10 to the 12th, which is 1.0 times 10 to the negative 12th. Right, and that's that. Now that we have a better understanding of how pH works, let's talk briefly about the pOH scale. Since pH measures acidity and uses the concentration of hydrogen ions, pOH measures alkalinity and uses the concentration of hydroxide ions. They use the same formula, replacing hydrogen ions with hydroxide ions, and the scales are switched too. A lower pOH means more basic, while a higher pOH means more acidic. This won't come up much unless you take chemistry courses in college, but it is worth knowing that the pOH scale exists and that the pOH of a solution plus the pH of a solution equals 14. This means that a solution with a pH of 2 must have a pOH of 12. Pure water, with its pH of 7, has a pOH of 7 as well. Let's review. The pH scale measures the concentration of hydrogen ions in a solution. Low pHs are acidic, while high pHs are basic or alkaline. The pH is calculated by taking the negative log of the concentration of hydrogen ions, which we can reverse to determine that the concentration of hydrogen ions equals 1 divided by 10 to the pH. Lastly, the pOH scale, which is basically the opposite of the pH scale, measures the concentration of hydroxide ions. That's it for this video. Thanks for watching, and see you next time.